Okay, so we're getting ready to start a new unit, and we're going to start this unit with something you've done before. So we need to use a refresher, and we're going to talk about unit rates of proportional relationships. The lesson objective for this lesson is that by the end of the lesson, I can find the unit rate of a proportional relationship from a table or a graph. Okay, so that sounds like a mouthful, but this is something that we've actually done before. We've used unit rates and proportional relationships. We've looked at tables, we've looked at graphs, but this is a refresher on that so that we can start talking about slope, which we'll be doing soon. Okay, so first let's talk about vocabulary. Let's talk about proportion and proportional relationship. Believe it or not, these mean really the same thing, but you're going to hear us use both of these words and phrases, and I want to make sure you understand what they mean. Proportions or proportional relationships are two ratios that are equal to each other. Two ratios that are equal to each other. Both proportion and proportional relationship really mean the same thing. It means that if you have two ratios or rates that are the same or equal, then the data you're looking at has a proportional relationship. Unit rate is when a rate or ratio is expressed as a quantity of one. For instance, 45 miles per hour speed limit. That is a unit rate because it's 45 miles in 1 hour. So it's a quantity of one. $3.50 per pound. That is a unit rate because it's $3.50 for each pound. Okay? And then origin. Origin is the 0, 0 coordinate on a graph. Sorry about that. Or coordinate plane. And that's going to be real important when we talk about proportional relationships. All right, so here's a reminder. How do I know if a relationship is proportional? Well, there are three things that you're looking for to find out if a relationship is proportional, okay? The first is there a constant rate of change? Well, that means, is there a constant rate from one piece of information to another? Okay. The second is, does it pass through the origin? Well, we talked about the origin is 0, 0. And the third is, does it make a straight line? You can test these with a table or a graph at any time. Okay, so I've got a table and a graph. And the table and the graph go together. They are for the same information, okay? So we can look at the graph to see if it passes through the origin, and we can look at the graph to see if it is a straight line. But we have to look more at the table for that constant rate of change. Here's what that means. This is your X value and your Y value in a table. And we're going to turn this hours per miles into a rate, okay? So what we're going to do is we always put the Y over the X. So the 50 over 1, okay? Here's how we know if this is proportional. We take the second ratio and we do 100 over 2 and we make them equal to each other. And if you remember back last year when we were talking about proportions, the way that you can tell whether this is a proportional relationship or not is to cross multiply. So 100 times 1 is 100 and 50 times 2 is 100. If these are equal to each other, then it is a proportional relationship. Now, you want to make sure to check more than one set of ratios, okay? You want to make sure that you check more than one, normally if you do not have a table. But what we know is as we're looking at this, it has a constant rate of change. So that's number one. Yay! We know that part is proportional. Then we say, does it pass through the origin? Well, when I look at the graph, it's 0, 0. I could also put the 0 in my table to see if the pattern makes it 0, 0, and it does. So yes, this passes through the origin. And then the last check is it a straight line? Well, when I look at it, it is a straight line. So, is this a proportional relationship? Yes, it is. All right, so now I have a table and a graph of the same information, and we're going to check it. Okay, so we have $1.30 over 1 mile. And then we also have $1.60 over 2 miles. So we're going to cross multiply. 2 times $1.30 is $2.60, and 1 times 160 is 160. Well, here's what we know. Oops, I'm sorry. Let me go back. Hit the wrong button. I did it twice now. These are not equal, so we know that it is not a constant rate of change. We're going to look at the other checks also just to be sure. Does it pass through the origin, or 0, 0? Well, let's look at our graph. Does it? It does not pass through the origin, so it doesn't cross that either. And is it a straight line? Yes, it is a straight line. But in order to be proportional, it has to pass all 3 of these tests. And since it doesn't, then it is not proportional. All right, so we know what proportional is. We know how to find out if it is proportional. What do we do when we have a relationship that's proportional and we want to find the unit rate? Well, we know that unit rate, okay, unit rate means when you're comparing a ratio and you have a quantity of 1. Well, let's look at this table right here. I have the number of days that I'm driving compared to the number of toll booths that I cross. Well, I don't have any 1s in there. So what I'm going to have to do is I'm going to have to set up my rate and then reduce it or divide it so that I can get a 1 on the bottom. So for instance, I can take any of these 3 data points. This is the X, this is the Y, okay? So I'm going to say 12 because Y always goes over the top, Y over X, okay, over 3. Well, I want a 1 on the bottom, and in order to do that, I have to say 12 divided by 3, so that is 4. So my unit rate for this particular table is 4 toll booths each day. So I pass through 4 toll booths on my way to work each day. Okay? So let's do one more. Why don't you try this one? This is servings of rice and beans and the protein in grams. I want to find the unit rate for this table. So you try it and then come back and see how you did. All right, let's see. So servings is X, protein in grams is Y. So I'm going to set up, I can take any of my pieces if I'm just going to prove that I can do any of these. So I'm going to use 63 over 3. And I take the top number divided by the bottom number, and that gives me 21 grams of protein for 1 serving. That's my unit rate. Pretty easy for a table. But what happens when I have a graph? Well, don't panic. Don't let this be crazy, okay? You're going to do the same thing, only you're going to look at a graph. You're not going to set up a rate and reduce it. Instead, you're going to find your 1. This is your X value. This is your Y value. Okay? So I'm going to find the 1 on my X value and follow it up until it touches my line. See that? It's right here. And then I go across, and what I find is that for every 15 muffins, there's 1 batch. So 1 batch of muffins contains 15 muffins. So I find the 1 on the X, then I go up to the line, and then I go across to find out how many that is. So let's do this. This is a 1, right? I go up until I run into my line, and then I go across. And so I see that the balloon is 40 feet high in 1 minute. So for every minute, my balloon goes 40 feet in the air. Over on this graph, every single batch has 15 muffins. So I can take this information and I can find out how many muffins there are in 25 batches, right? Or I can take this information about the height of that balloon and I can find out how many feet in the air it is after 4 minutes. It's a lot of really good information, and that's why we have to find a unit rate. Okay, one last thing. We're going to create a table and a graph from an equation. This is our equation, y equals 16x. Okay, we're going to use that equation to fill in our table and then fill in our graph. And it's really, really easy. All you're going to do is substitute values for x. And you can pick any values you want, but you're going to want to pick small values that are easy to plot on the graph. So for instance, I'm going to pick, remember this is my x, I'm going to pick 0 batches, 1, 2, 3, and 4. Okay, so then I'm going to go to my equation. I'm going to say y equals, because I'm trying to find the y, 16 times 0. Well, that's 0. See that proportional relationship? Okay, then I'm going to put 16 times 1. Oops, sorry, that's 11. Not 1. Which is 16. So this is 16. So then 16 times 2, which is 32. 16 times 3, which is 48. And then 16 times 4, which is 64. All right, now I'm going to go plot it. I know that my y goes on my vertical axis. So that's my total, let me turn this to the side, total muffins. Okay, and the bottom is my batch. And I'm sorry, I'm running out of room down here at the bottom. Okay, so now I need to plot 1, 2, 3, 4, 5. Okay, and then I'm going to plot my number of muffins. This is 16. I'm going to have to erase this so I can make it smaller. Sorry about that. 32. 48, and 64. So now I'm going to, these are ordered pairs. So 0, 0, let me use a different color. 1 and 16, 2 and 32, see my line I'm making? 3 and 48, 4 and 64. And when I connect those, if I had a ruler, I can't lay one on my iPad, I would see that I have a straight line. It goes through the origin. And so it is proportional. You're going to do a lot more of this, so write down any questions you might have.